Today, we tackle a fundamental question: who owns the Internet? The answer, perhaps surprisingly, is no one single entity. Unlike a utility company with a clear owner, the Internet operates as a vast, interconnected web. It's a decentralized network, meaning there isn't one central command center or a single switch that can turn it off. Instead, a complex ecosystem of organizations, governments, and private companies collaboratively own and operate its various components, forming the digital fabric we rely on every day. To understand Internet ownership, we must first distinguish between the Internet's physical and logical infrastructure. The physical infrastructure refers to all the tangible components, the cables, servers, routers, and towers that carry data. Imagine the Internet as a massive road system. The physical infrastructure constitutes the roads themselves, the bridges, and the traffic lights. These are the foundational elements that allow information to travel from one point to another, across continents and oceans, at incredible speeds. One of the most critical parts of the Internet's physical backbone are the submarine cables. These fiber optic lines, laid across ocean floors, are responsible for carrying approximately 99% of all international data traffic. These aren't just single wires, they are bundles of hair-thin glass fibers, transmitting data using light pulses. These cables literally connect continents, forming the high-speed arteries of global communication. Without them, international Internet traffic would grind to a halt or rely on slower, less reliable satellite connections. Who owns these vital submarine cables? The answer is typically large consortia. These are groups of multiple telecommunication companies and increasingly, major tech giants like Google and Meta. They pool resources to finance, build, and maintain these incredibly expensive projects. Each member of the consortium then owns a share of the cable's capacity. This shared ownership model spreads the immense cost and risk, while ensuring diverse interests benefit from and contribute to the global network's expansion and resilience. Once submarine cables reach land, they connect to what are called cable landing stations. These secure, purpose-built facilities act as the crucial interface between the undersea network and terrestrial, land-based fiber optic networks. These stations house the equipment that amplifies and processes the data signals, ensuring their integrity over long distances. They are often owned by the same consortia or individual telecommunication companies that own the cables themselves, serving as vital entry and exit points for global data. From the landing stations, data travels to data centers. These are physical facilities housing servers, storage devices, and networking equipment. Think of them as the Internet's digital warehouses, where vast amounts of information are stored, processed, and routed. Every website you visit, every streaming video you watch, and every email you send likely passes through multiple data centers. Their security, cooling, and power infrastructure are immense, designed to ensure continuous, reliable operation around the clock. Data centers are owned by a diverse group of entities. Major players include colocation providers, which rent out space and infrastructure to other companies. Then there are the massive cloud computing companies, such as Amazon Web Services, AWS, Microsoft Azure, and Google Cloud, which own and operate vast networks of data centers globally. Large enterprises also own their own private data centers to host their specific applications and data. This distributed ownership model reflects the vast and varied needs of Internet services. As data moves between different networks, for instance, from your Internet service provider to Netflix's servers, it often passes through an Internet exchange point, or IXP. An IXP is a physical location where multiple independent networks, such as ISPs and content delivery networks, directly interconnect. Instead of routing traffic through a third-party, potentially slower, connection, IXPs allow networks to exchange data directly and efficiently. They are crucial for keeping Internet traffic flowing quickly and cost-effectively within regions. IXPs are typically operated by non-profit organizations, universities, or commercial entities. Their role is to provide the physical infrastructure and governance rules for the interconnection, not to act as a middleman for the data itself. The networks connected to an IXP agree on peering agreements, which dictate how they will exchange traffic. This collaborative model prevents any single entity from monopolizing traffic exchange, promoting a more open and resilient internet architecture for users and service providers alike. Finally, bringing the internet into your homes and businesses are internet service providers, or ISPs. Companies like Comcast, AT&T, and Vodafone own the local infrastructure, the fiber optic lines, coaxial cables, and wireless transmitters that connect you to the broader internet. They purchase bandwidth from larger backbone providers and then distribute it to their customers. ISPs are the gatekeepers of your personal internet access, forming the critical last-mile connection that makes the entire global network accessible to you. For mobile internet access, another layer of physical infrastructure becomes essential: wireless towers and antennas. Mobile carriers like AT&T, Verizon, and T-Mobile own and operate these extensive networks. These towers transmit and receive radio signals, allowing your smartphone or other wireless devices to connect to the internet. While they rely on the same fundamental backbone infrastructure of fiber optic cables for long-haul data, the local wireless network is a distinct and privately owned component, constantly expanding to meet demand. Beyond the physical cables and servers, there's also the internet's logical infrastructure. This refers to the systems and protocols that enable communication and address data correctly. A key component here is the IP address. Every device connected to the internet, from your phone to a web server, has a unique Internet Protocol (IP) address. Think of it as a digital street address, allowing data packets to be routed to the correct destination, much like postal mail needs a precise address. The management of these IP addresses and domain names falls under the purview of ICANN, the Internet Corporation for Assigned Names and Numbers. ICANN is a non-profit organization established in 1998, responsible for coordinating the global Internet's unique identifiers. They don't own the Internet, nor do they control content. Instead, they ensure the stability and interoperability of the Internet's addressing system, acting like a global address bookkeeper. This critical role ensures that every device can find every other device reliably. ICANN delegates the allocation of IP addresses to 5 regional Internet registries, or RIRs. These include organizations like ARIN for North America and RIPE NCC for Europe. Each RIR manages IP addresses and autonomous system numbers within their specific geographic region. They then distribute these addresses to ISPs and other organizations. This tiered structure ensures efficient and localized management of a global resource, preventing conflicts and ensuring that new connections can always find a valid address. While IP addresses are crucial for machines, domain names are what humans use. A domain name, like youtube.com or google.com, is simply a human-readable alias for a complex IP address. It's much easier to remember a name than a string of numbers. Domain names are purchased from domain registrars, which are companies accredited by ICANN. When you buy a domain name, you're not buying the internet itself, but rather the exclusive right to use that specific name for a period, linked to an IP address. The system that translates domain names into IP addresses is called the Domain Name System, or DNS. Think of DNS as the Internet's phone book. When you type youtube.com into your browser, your computer consults DNS servers to find the corresponding IP address for YouTube servers. Once it has the IP address, your computer can then connect directly to YouTube. This intricate, globally distributed system is vital for navigation, making the internet user-friendly and highly functional for billions. Beyond addresses, the internet also relies on a set of standardized rules called protocols. These protocols dictate how data is formatted, transmitted, and received. Key examples include TCP/IP, Transmission Control Protocol/Internet Protocol, which governs how data packets are sent and reassembled, and HTTP, Hypertext Transfer Protocol, used for web browsing. These are open standards, meaning they are publicly available specifications, not proprietary technologies owned by a single company. They are the universal language of the Internet. These crucial protocols are developed and maintained by various organizations, notably the Internet Engineering Task Force, IETF, and the World Wide Web Consortium, W3C. The IETF focuses on the core Internet protocols, like TCP/IP, ensuring the Internet's foundational technologies evolve collaboratively. The W3C, on the other hand, develops standards for the World Wide Web, such as HTML and CSS, which shape how websites are built and displayed. These bodies are non-profit, volunteer-driven, and aim to keep the Internet open and accessible to all. In summary, the Internet's ownership is a mosaic of different entities. No single government, company, or individual holds the reins. Instead, a vast, collaborative ecosystem of private companies, non-profit organizations, and academic institutions collectively build, maintain, and govern its physical and logical components. This decentralized, shared ownership model has been fundamental to the Internet's resilience and its ability to grow into the indispensable global resource it is today. It's a testament to distributed effort. Understanding who owns and operates the Internet's infrastructure reveals a system built on cooperation, standardization, and distributed control. From the giant undersea cables connecting continents to the smallest local ISP, each piece plays a vital role. This intricate web ensures that our digital lives, from sending an email to accessing cloud services, remain seamless and efficient. As technology continues to evolve, this collaborative ownership model will be crucial in navigating the Internet's future, addressing challenges, and ensuring continued innovation and access for everyone.